Hi everyone, I think we can probably start. Thanks for joining this session. I hope you're having a great conference. I know I am. It's so great to be here at Spring I/O for the 10th edition. Today I'm here to talk about multi-tenant applications. So how many of you are working with multi-tenant applications? I'm curious. All right. So how many of you find it challenging to work with multi-tenant applications? Yes. Yeah, it is challenging, right? So I'm Thomas Vitale. I'm a software engineer and cloud architect at Systematic in Denmark. I'm really passionate about anything about Java, Spring, Cloud Native. I combined all these passions and wrote a book. It's called Cloud Native Spring in Action with Spring Boot and Kubernetes. And I'm a big supporter of open source technologies and try to contribute as much as I can, both in the Java space and in the Cloud Native ecosystem. So, multi-tenancy. Let's start by talking about what is multi-tenancy, why do we need it, and what problems we are trying to solve. Multi-tenancy is an architecture. It's an architecture in which a single running instance of an application simultaneously serves multiple clients that we call tenants. That's how the Hibernate user guide defines it. And this type of architecture is highly common in software as a service solutions. So we have a single instance of our application, and we serve multiple customers. So we're talking about a higher level compared to normal applications where we have perhaps the possibility to have different user accounts logging in, but now we want to group those users into tenants. So each customer will purchase a subscription to use our software, and then within each customer, within each tenant, we're going to have multiple users. And the reason why this architecture is so popular is that it allows us to optimize cost in production. So with regards with operations, with regards with maintenance, with regards with resources that we need. Because without multi-tenancy, then every time we get a new customer, every time we need to serve a new tenant, then we would have to spin up a different instance of our application. And that's really not scalable. So that's why we build multi-tenant application. Now, consider a building with multiple apartments. And these apartments are inhabited by rock bands. So each apartment will have a tenant, which is a rock band with different musicians. They will share the infrastructure, they will share the staircase, the elevator, the roof. We want to optimize cost, so we don't want to build a different house for each rock band. We want them to share the same building, so we can optimize all these operations cost and maintenance cost. But then each tenant, each rock band, has access to its own apartment, to its own private storage, where they can safely store their musical instruments. However, every bean has a secret. We're going to see how to build multi-tenant applications using Spring. We're going to use Hibernate, Micrometer, Keycloak. However, something will not look quite right. So I'm going to ask you to pay attention, to focus on what I'm going to do, because something will be wrong. A guitar was missing. Like one of the rock bands reported that they can't find their guitar anymore. And in their place, there's a duplicate, there's a fake one. So we need to solve this mystery. So pay attention. At the end, I'm going to ask the question, and I'm going to give away a copy of my book. So if you can find the mystery, if you can solve the mystery and find the stolen guitar. So let's get started. We start by our baseline standard application, standard Spring application. We need to introduce the concept of a tenant. So first of all, we need to define a way to resolve the tenant. Let's say we have a web application. An HTTP request is coming into our application. We need to resolve the tenant information from that request. So we need to define some kind of tenant resolver, and we can resolve it starting from an HTTP request, if it's a web application, but it could be a message, for example, coming from RabbitMQ, or it could be even a claim inside a JSON Web Token. So we need to know where to find the information about the tenant associated to a specific request. Next, we need to extract that information and store it somewhere, store it in some kind of tenant context that can be accessed for the whole duration of the request processing, so that other components in the system can understand and know which is the current tenant for the current process. And finally, we need some kind of interceptor. So we receive this HTTP request. We need some interceptor so that can intercept the HTTP request, use the resolver to extract the tenant information, and then store it inside the tenant context. So let's have a look at how that works in practice. I'm going to work with a Spring Boot application. Now I can use Spring Boot 3.1.0 that was released yesterday. For now, I just need the Spring Web dependency. I have it already open. This application will allow these rock bands to manage their instruments. It's an instrument service application. I have already defined an interface. You can see this tenant resolver interface that we can implement to resolve the tenant from different places. In particular, we want to resolve it in this example from an HTTP request. So let me implement that. We're going to extract information from an HTTP header, tenant resolver, and we're working with a Spring MVC application. So the resolver will work based on an HTTP servlet request. Servlet. Come on. HTTP servlet request. All right. Now we can implement the method. And we said we want to resolve the tenant starting from the HTTP header. So in particular, I'm looking for a custom header. I can define how it's named. For example, X tenant ID. So if I send a request with that custom header, with information about the tenant identifier, then I can use that information to process the request for that specific tenant. However, I don't like hard-coding the value there. I want to make it configurable. So I have already created a bin to do that. So I have an HTTP, a tenant HTTP properties bin that I can use. Let's auto-wire it, constructor injection, and we get rid of this hard-coded value, which is not that great. And then in the application property file, you can see that I have defined this custom header as a custom property, X tenant ID. That was step one. We know how to resolve a tenant from an HTTP request. Great. Next step, we need to establish this place where to store temporarily the information about the tenant. And since I'm working with the Spring MVC application, it's an imperative application, I can rely on a thread local object. So I have created this tenant context class with a thread local that will contain my tenant identifier. And I have three methods here to set the current tenant, to retrieve the tenant, that's useful as part of processing the current request, and then to clear the tenant at the end of the processing, when the request has been fulfilled. And finally, we need the interceptor. Again, we are using Spring MVC, and Spring MVC provides an interface called a handler interceptor, which allows us to intercept a request and do something before and after the processing. So it's in here that then I can use both the resolver and the context. So let me auto-wire the HTTP tenant resolver like that. And then we can use it. So before processing the request, what we want to do is using the resolver to get the tenant ID. Resolve the tenant based on the current request. And then we can set it in the context. So set tenant ID. Perfect. Then we have other two methods that this interface exposes that are executed after processing the request. One when the request is successful, the other one even if there has been some exception. So in both places, I need to make sure that I clear the tenant context. And just to avoid some duplication, I'll define a method called clear, where I can say tenant context dot clear, and then I call it from both places. 1 and 2. So to sum up, I have the interceptor. I intercept any HTTP request. Before processing the request, I extract the tenant identifier, I configure the context, and then my request will be processed in the context of that tenant. The last thing I need to do is providing this interceptor to the Spring MVC configuration. So first, where's the resolver? I need to mark this as a component, so Spring will find it. And then I need to provide the web configuration. So I can implement the web MVC configurer that provides a method to add interceptors to the application. So I can say interceptor registry, add my tenant interceptor. All right. So at this point, every request, if I provide that HTTP header, will know what is the current tenant. So I can, just to test it out, I can define a REST controller to return the current tenant. And in this method now, and anywhere else as part of the processing of the request, I can say tenant context dot get tenant ID. All right, let's verify that now everything is working correctly before moving on. The application is running. It's running on port 8181. Let's see if the tenant endpoint is working. I need to pass this custom header, X tenant ID, for example, for the Dukes rock band. And we see that we get back the tenant for the current request. Let's try with another value, the beans, and there it is. All right. Phase one is done. Now that we have this tenant context established, we need to start talking about data isolation. Now, this is probably the most important part of a multi-tenant application, because we get a lot of benefits. We want to optimize cost, resources, and use the same application to serve multiple tenants. But the downside is that now we have a problem on how to properly isolate data between customers. Probably our customers don't want their data to be mixed up with other customers' data. And if we're working in highly regulated industry, that's not even just a bug if we do it. I mean, that's breaking the law. Think about healthcare, for example. So we really need to pay attention to this part, how to isolate data between tenants. In general, we can identify three main strategies. The first one is partitioning data based on a discriminator. And it seems very straightforward to begin with. We basically add a new column to all our tables with the tenant identifier. But then the catch is that we need to make sure that any kind of SQL statement we execute contains that discriminator. And there are so many ways that we can perform an SQL statement on a database from our Java application. So it's quite dangerous if we allow too much here, because there's no automated way to know 100% that we covered all the possible entry points to the database. So if you're using this method, really consider if you really want to use it. First thing, I don't see it much used, to be honest, in the real world. But if you do use it, pay very much attention to all the possible ways that we can call the data. Because if we forget one place and forget to add a tenant ID, then we expose data from other customers, and that's really not what we want to achieve. Next strategy is based on a separate schema. So we use the same database, but then within the same database, we have different schemas, one for each tenant. Basically, we are duplicating the tables. We're talking about musical instruments, so probably we're going to have an instrument table. For each tenant, we're going to create an instrument table within this schema partition. This is a good trade-off, because we are not exposing this tenant information up to the SQL statement, but this will be handled at the lower level, at the connection level. So we have a connection to the database, and when we send an SQL request, an SQL operation, then the connection will switch between schemas based on the current tenants. So from a developer perspective, we don't need to worry about remembering to add the tenant ID discriminator, because it's handled at a lower level. Then finally, we can go with totally separate databases. This is the higher level of abstraction or isolation. We have different databases, so every time we process a request for a tenant, then we simply point to a different database based on the tenant. This ensures the maximum degree of isolation in a multi-tenant application, but also you need to consider that you're going to use more resources, because now you need a different connection pool to connect to each different database. So it's a matter of trade-off and what are your requirements. It's great to have these strategies available, and if you're using Hibernate with Spring Data JPA, you have support for all three of them. In this example, we're going to use the separate schema strategy. So let's have a look at how that works. I'll stop the application and switch branch. So what I'm doing now is adding a bunch of new dependencies. So if we go back to the Spring initializer, I want to add Spring Data JPA, which includes Hibernate under the hood. I'm going to work with Postgres, so I'm adding the PostgreSQL driver. I'm using test containers to spin up a PostgreSQL container, not only for testing, but also development time, since I'm using Spring Boot 3.1, and perhaps Flyway to deal with data migration. All right. So the first step is actually pretty standard. We have an instrument entity. I'm using JPA, so it's a JPA entity with 3 fields. I have an ID, I have a name, and a type. I want to point out this ID, in particular the type, UUID, because this is something new in Jakarta EE10. So since I'm using Spring Boot 3, I can rely on this generation strategy to generate the value as a UUID directly, which is pretty nice. And then we have, a name and a type. So far, pretty standard. Nothing about tenants. On top of that, since I'm using Spring Data, I can define an instrument repository. I define just the interface because Spring Data will automatically provide an implementation for me with all the most common operations for creating, reading, updating, and deleting instruments. And then I also define the custom method here because I want to be able to look for instruments by type. And finally, a controller, where we expose these /instruments endpoints in order to retrieve all the instruments, calling repository find whole, find by type, to return instruments by type, and then to save instruments. So far so good, nothing tenant specific. Now what I would usually need to do is go in my application property file and configure the data source. So I would need to define the URL, the username, and the password. But as I said, I'm using Spring Boot 3.1, and I'm using test containers, so I don't need to do this, because I can directly configure a bin in my test configuration and provide a PostgreSQL container there, relying on test containers. So let's do that. Return a PostgreSQL container like this, and in particular I want to use version 15. And since I'm, again, new feature in Spring Boot 3.1, I can annotate it as service connection, and by doing this, Spring Boot will get the information from the PostgreSQL container, URL, username, and password, and configure them automatically into my application. So I don't have to do it myself, which is really, really convenient. Now I can use this test configuration for running my test, like integration test. For example, I have here an empty test. I can import the test configuration, and then automatically I will get my database running as part of the test. But I can also use it at development time to run my application locally while building new features. For that, I need to create this test application. So I have a Spring application. First, I need to create this one. Main method, new entry point for our application. We're gonna base this on the instrument service application. So it's the regular application, but on top of that, I'm applying this test containers configuration. So I'll say with test containers configuration, and then run the application with these arguments. So now I can run it from here. For example, I'm using Gradle here. Instead of running boot run, I would run a boot test run. Or I can also do it directly from the IDE. But now I cannot just run my application, because where are the tenants? Like so far, everything was standard. Now on top of that, I need to implement this schema strategy. So I need to have a different schema for each tenant. I have created a simple SQL script here where I create 2 schemas, one for the Dukes tenant and one for the Beans tenant. And this is what the strategy means, like separating by schema. I have the same table, the instrument table, but duplicated in each of the schema. So one within Dukes and one within Beans. Now, in a real-world scenario, you wouldn't do this. You would have your instrument table definition and then use Flyway to iterate through the list of tenants and apply that. I'm doing this just to make it clear about the schemas and that we have the same table inside the schema. Final thing, we are using Hibernate, and Hibernate needs to know 2 things. Because from our repository interface, we know nothing about the tenant. So Hibernate, at the lower level, need to know how to resolve the tenant for the current request, and how to map that tenant to a schema, so that every time it opens a connection to the database, it does it towards a specific schema based on the tenant. And luckily, Hibernate provides 2 convenient interfaces to do that. The first one is called a current tenant identifier resolver interface. So what I do here is telling Hibernate how to resolve the tenant. And the good news is that we already know. We built the tenant resolver earlier. So what I'm going to do here is using the tenant context to retrieve the tenant. because I know that I have already said that. But also, I need to define a fallback. So if the request is not part of a tenant, is not context specific, then I'm gonna fall back on the public schema. This is something that comes out of the box with Postgres. In a real world scenario, you might want to create a separate schema yourself called master or main, where you want to store your data that are not tenant specific. In my case, I don't need that, so I'm fine with just using the public schema. And then, now this is interesting because Hibernate doesn't allow Spring to tell it, use this tenant identifier resolver, even if it's marked as a component. So we have to tell Hibernate explicitly. And that's why I'm implementing a second interface called Hibernate Properties Customizer. This is a convenient object that comes from Spring Data JPA that allows us to do exactly this. So I can say Hibernate Properties put, and then get one of the Hibernate available settings. In particular, I want to tell Hibernate that as a multi-tenant identifier resolver needs to use this same class. So I'm gonna say this. That's one thing. Now Hibernate knows how to resolve a tenant for each connection to the database, for every time it needs to perform an SQL operation. Second thing is how to map this information to a schema. And for that, we have a separate interface called Multitenant Connection Provider. So it's in here that Hibernate will provide a tenant identifier, and we need to set the schema. So since we are working with connections, I need to inject in here the data source that is auto-configured by Spring Boot. Constructor injection. And now we have this get connection method. We can see that Hibernate will inject automatically the tenant identifier based on the strategy we provided. So we can obtain a connection from our data source. And the default behavior here would be to just return the connection to talk to the database. But we need to specify which is the schema we want to talk to. So we have this extra step where we set the schema, which in our case is equal to the tenant identifier. So it's quite convenient. We don't need any additional mapping. We know the tenant identifier, we use it as a schema, and then Hibernate will either call the Dukes tenant or the Beans tenant based on the context. And then when we release the connection, I'll close it, but I also need to reset it, so to have the default schema public. Then I also need to implement these other two methods. These are more generic, so I can just use the public schema. And that's it. Now, once again, Hibernate doesn't allow Spring to tell it, please use this connection provider. By the way, there's a feature request opened on the Hibernate issue tracker, so hopefully in the future we won't need to do this, but for now we need to implement this Hibernate Properties Customizer and once again explicitly tell Hibernate to use this class. So I have this customize method in here. I can say Hibernate Properties, put, and then available settings, and we're talking about the multi-tenant connection provider. So please, Hibernate, use this class to configure these connections. And that is actually it. So let's see if it works. I'm gonna run the application from the test context. So I will get test containers to spin up the PostgreSQL database automatically. And it seems that it's running. So now we can give it a try. Yeah, so we have now a new endpoints to retrieve all the instruments. Let's say we are within the Dukes tenant now. So of course, there's no instruments yet. So let's add one. I want to add a piano, a Steinway piano. Type is piano. Like that. So we created data. It worked. Let's retrieve once again the instruments for Dukes. So we can see that there's one single instrument for now. But what happens if I switch tenant? Let's verify that. Beans, and it's empty. So it seems like the data isolation is working quite fine. Now, before moving on, since multi-tenancy is a pattern that is usually used in enterprise applications where you have a lot of customers, a lot of tenants, and performance can become a problem, it's also quite useful to introduce some caching. And with Spring, we can do that pretty easily. I can add the Spring Cache abstraction, which comes from Spring Framework, and then identify some kind of backend, for example, Redis. For now, I'm using the in-memory version for simplicity. So I can do, I don't know, just as an example, let me enable caching in the application and enable caching. And then perhaps we can cache one of the endpoints, like this one. I can say cacheable, cache names, instrument types. All right, that's quite simple. Now, moving on. Because we are introducing quite some complexity, right? I mean, we identified a strategy to isolate data that allows us to use our Spring Data repositories in the normal way, but still, when it comes to debugging, to troubleshooting, if there's an incident that is reported by one of our customers, we might be in serious trouble if we don't have the right observability in place. We need to get visibility into not only the application itself, but also to distinguish between what operations are performed by which tenant. So we need to rethink our observability strategy a little bit. For example, when it comes to logs, we might think to include the tenant identifier directly in each log message, so that we know that that log message belongs to a specific tenant. If we consider metrics, well, this depends on our requirements. In some cases, we might want to use metrics just to monitor the overall behavior of our application. In some other cases, we might want to have a tenant context also within the metrics. So being able to query metrics by tenant ID. And same thing for traces. We need to be able to identify traces based on the tenant that was part of the context of a specific request. So if the customer Dukes then reports an incident, then we can look and check for all the logs and traces that belong to that tenant, for example. So going back to our Spring Initializer app, now I can add a few new dependencies. I have the Spring Boot Actuator, which provides a lot of convenient endpoints out of the box for monitoring and managing my application. For the metrics, I want to use Prometheus. Then I'm using Spring Boot 3, so I can take advantage of the new distributed tracing capabilities provided by the Micrometer tracing project. And then I'll use OpenTelemetry. It's not available here yet, but it's something new that has been added in Spring Boot 3.1. For now, you can choose Zipkin, but we'll be using OpenTelemetry under the hood. So moving to our code again, I'll need to switch branch, like that. So by default, by adding all of these dependencies now, I get already out of the box a lot of functionality in regards to metrics and traces, because now, starting from Spring Boot 3, each module in the Spring project provides instrumentation for its own objects. And that's quite convenient, but when we are in a multi-tenant application, we need to do something more in order to add that contextual information coming from the tenant context. And if you remember, we introduced a tenant identifier earlier, a tenant interceptor, where we extract the tenant identifier and configure the tenant context. So this could be a good place to also provide this contextual information to logs, metrics, and traces. Let's start with logs. Now, when we work with logs in Java, usually we use this SLF4j. It's an abstraction that then is implemented by libraries like Logback, which is the default in Spring Boot, or log4j. And this object is basically a map where we can store contextual information and use that information when we define the pattern for our log message. So if I want to have in my log message the tenant identifier, I can add to this object, again it's a map, I can add an object with key tenant ID and pass the value. And then once again I need to clear it. We should remember that. Like that. So now in the logs I will get the tenant ID. Next, I need to consider metrics and traces. And because I'm using Spring Boot 3, I can rely on the new Micrometer API. It's called the Observation API, which unifies metrics and traces together. So I can configure them using the same abstraction. The Observation API is used throughout the Spring portfolio. In particular, there are some filters that are auto-configured in order to create and manage metrics and traces based on the operation. Now we are working with HTTP request here, so I can rely on the server HTTP observation filter. This is something that comes out of the box for me. I'm not creating this, but I want to hook into this filter in order to add my tenant ID information. So I'm adding new contextual information. From here I can get the current observation context for the current request. And then if it's present, I want to get that context. And in the context now, I can add my tenant ID information. But I have to make a decision. I have two options here. I can add it as a low cardinality key value or high cardinality key value. And what it means is related to how we work with metrics and traces. Because traces, usually we generate traces for a lot of traffic. And if we set up a high cardinality value here, we probably don't want to include the same information in the metrics, because metrics are quite expensive. If we have keys that can have unlimited number of values, it becomes really unpractical to work with metric with so many key value pairs. So we want to use a low cardinality key value if the key has a limited number of values. But if it's unbounded, then it's better to use a high cardinality key value. Also, we need to consider whether we want metrics to be to know about the tenant or not. So in this case, I just want the tenant information part of my traces. So I'm going to use a high cardinality key value in here. So I can say key value, and then identify the key as tenant.id. I use the dot notation from Micrometer and pass the tenant ID. Later today, there will be a presentation about observability in Spring, so if you're interested, you can. I really recommend joining that presentation to learn more about how this works. But for our purpose, this is fine. Now, for every request, we'll get the tenant ID also in the logs and in the traces. Or we should get them, so let's verify. I'll run the application again. Or I'll try to run the application again. Okay. My laptop just crashed. Nice. So now we have two mysteries to solve, right? So who stole the guitar and who crashed my computer? So I'm curious, who is already using Spring Boot 3.0? Nice. Oh, your computer was restarted because of a problem. Thanks for being so specific. Like, I really like the details. What problem? Well, anyone updated to Spring Boot 3.1 last night? No? Oh, wow, nice. Yeah, I have to be honest. So I'm using 3.1.0, but the latest release candidate. So I didn't have time to update the demo, but I'll do. All the code is on GitHub, so you can have a look at it. Let's start Dogger again. The presentation is open. Fun stuff. So in the meantime, I can say a little bit more about the two dependencies that I used. So I used, where it is. Oh, maybe it's just starting. We should be lucky. Yeah, so back to the editor. In here, we want to run the application. Oh, no, the wrong application. This one. Come on, come on. Let's go back to our tenant test instrument service application and IntelliJ's indexing. We'll do it from the console boot test run, so I can also show you the other way of doing that. So now once again, test containers will spin up the PostgreSQL database. We're gonna get all the, let's see, it started, or maybe not. Probably Dogger issue. Yeah, that shouldn't be there. All right. Let's see. This is fun. Well, I always love doing live demos. I might get issues, but I mean, I'm not gonna stop them. It's so fun doing some live coding. All right. Let's do a hard restart here. what do we have here? All this stuff. I wish there was a remove all command. I mean, it's available in Podman, but yeah. All right, Docker compose up. Yay. Let's see if we can get the application started. Terminate. Run again. Stay with me and start thinking, or continue thinking about what problems we had besides the crash, because we're getting closer to solving the mystery, or we should get close to solving the mystery. Yes, we went through. All right. Fun stuff. Yay. So back to the console here. Let's try to send a request to the /instruments endpoint for the tenant ID Dukes. We get a bunch of instruments. We want to verify the observability stuff, right? I have the Grafana observability stack already set up. So I can go there and check the logs using Loki. That's the logging solution in Grafana. Let's check the logs for instrument service. All right. Is it big enough? Yes. We can see that we have the message here, return all instruments, but we're not getting the tenant ID. And that's probably because of the application in here. It didn't save my changes, apparently. Nice. So let's do it again. So remember, we have this the interceptor where we intercept the request, and we set up the logs, we set up the traces, and we set up the tenant context. All right. One more time. No, I don't want that. Go away. Go away. Yes. All right. Let's check the logs one more time. Instrument service. Go. You think it's going to crash again? Oh, well, we can see it here also. So that's too low. Okay. I want this to work. Oh, nice. It changed color. That's magic. All right, but we get the tenant ID information. We get the trace ID information. We can navigate to the trace. Let's do that. And we have all the trace information down here. And what we are interested in is checking the tenant information, if it's actually there. So let's verify. We have this HTTP get instrument span in here. We have a bunch of attributes configured automatically by Micrometer and OpenTelemetry, and there it is. We have the tenant ID Dukes. So now we can search for traces based on the tenant ID. Nice. Now I want to get rid of something else because I'm getting tired of keep writing that X tenant ID. Also, our users, our customers will not set up that header. That's something internally in our system that we decide to use. Because what usually a customer would do is sending a request to something like dukes.rock/instruments, right? So each customer, each tenant would get its own DNS name. So let's configure that. I can introduce some kind of gateway that will read the DNS name, extracts the part that corresponds to the tenant identifier, and then add the request header, xTenant ID, internally for all my other services. I can do it with Spring Cloud Gateway. So the way that it works is that I introduce a gateway in front of my service. So my customers will access the application from dukes.rock, and then the gateway will extract the Dukes part of the DNS name and set it as a custom header for the request. And then if some other customers calls the application from beans.rock, then xTenant ID equal beans. We can do it with Spring Cloud Gateway. So I have already set up a project, just gateway dependency, nothing more than that. And what I need to do is configuring the route. So I'm gonna have cloud gateway routes. So I can define an ID. So this route will be to forward request from the gateway to the instrument service. And this one is specifically for the instruments. We have instruments route. We want to forward request to my local host on port 8181, which is where my application is running. We have some predicates. So we want to know when to trigger this route. So I can say path equal instruments. So all the endpoints starting as /instruments will go in here, but also we want to identify a specific pattern for the host name. So I can say host, let's call it segment.rock. And now I can use the filters that come out of the box with Spring Cloud Gateway in order to extract that information and add it as a request header directly. So I can say X tenant ID segment. That's it. Now I'll run the application. It's running. So let's see if it works. Now I can send a request to dukes.rock/instruments. And I get the instruments for the Dukes tenant. Internally, then it's adding that request header that will be used by the instrument service to extract information and set up the tenant context. Nice. We are almost to the end because we have one last thing to consider, which I think after data isolation is probably the other important thing when we talk about multi-tenancy, which is security. Because now on top of what we usually do with authentication and authorization, we need to consider that we have different customers with probably different identity providers. So if we look at the authentication part, we're probably going to have separate identity providers. So if the Dukes tenant will access the application, then we need to delegate the authentication step to the specific identity provider for the Dukes tenant. And if it's the beans customer calling the application, we want to redirect to the beans IDP. And the important part is that we don't want to have this configuration hard-coded into our application. We want to be able to dynamically start serving more customers. And the same thing happens for authorization. So what we usually do with Spring Security and OAuth to client is that we define something like this in the property file, right? Where we specify how to access, in this case, Keycloak, the identity provider, the issuer URI, and then everything will work out of the box through auto configuration. But in our case, we don't want to add that type of properties for each of our tenants. What we want to do is creating a custom client registration repository, which will dynamically create that same configuration, but based on the tenant ID. So that based on the tenant, we call a different issuer URI. And the same approach is for the backend part, for the instrument service, because the instrument service will receive a JSON Web Token from Spring Cloud Gateway, specific for the Dukes tenant. And then from that token, what the service needs to do is calling the IDP for Dukes in order to get the public certificate and verify the signatures on the token. So we need to verify that its integrity. And once again, we want to do it dynamically so that if we add more tenants, then we can dynamically resolve that information without changing our code. And once again, we wouldn't be using something like this. This is the standard way of doing it with Spring Security OAuth 2 resource server. We point to the issuer URI that we use to verify the JSON Web Tokens. We want to do it dynamically. So we have the same configuration, but based on a tenant, and we can use a bean called Authentication Manager Resolver. Now I won't show the code because it's a lot of it, so you can check out the GitHub repository, but for me it's important to deliver what is the strategy behind this. The main idea is that we want to resolve this mapping between tenants and authentication identity provider in a dynamic way, so that we don't have to change our code, and at runtime we can just start serving more tenants, more customers. So let's look at how it works. Switch branch. Yes. So I am using Keycloak right now. So Keycloak has the concept of a security realm. So I have created two different realms, one for Dukes and one for beans. So using Keycloak, you can have, for each tenant, you can create a different realms. Let's start the application. I can also show you Keycloak very quickly. So I have two realms in here, one for Dukes and one for beans. So now dynamically my application based on the tenant will call the specific Keycloak realm for that tenant. Let's see if that works. I can say local, no, we now have dukes.rock/instruments. Now we're redirected to the Dukes specific login page. So I can log in with one of the users in that realm, in that tenant, and then I get the result back. Nice. But there's one more thing that is missing, right? So what about the guitar? Because the Duke's band reported that the guitar was missing, and they are accusing the Beans band. So what's going on there? Let's see what's the problem. Now, just for simplicity, I'm going to disable the authentication step. So that's a clue. The authentication is correct. It's not where to look for clues for mysteries, but what I can do is, or I can actually go and do this something else. Okay. Let's start the application. So I have a script to simulate some load on the application so that multiple tenants and multiple users within each tenant are logging in. I think it's load up. Let's verify that they're both working. They are. All right. So let's call the Dukes instruments. So we can see that the Dukes band has 3 instruments here: a Steinway piano, a cello, and a Gibson Fireboard, one of my favorite guitars. All good. But let's have a closer look at the guitars, because they said that the guitar is missing and that there is a fake one in its place. So something is fishy there. We have an endpoint that we can call to focus on the guitar. Let's call it. And wait. So now that's a fake Gibson Fireboard guitar. So something is wrong here. Have you seen? I see a hand down there. Let's have a look. That's a good suggestion. So I called this endpoint. I have observability in place, so we can probably use that to investigate. I have my tempo traces. Let me switch to light mode. Yeah, I'm on the light side here. Tempo, so I can search for all the traces belonging to the instrument service, and I can even search by tenant ID, because now I have that observability strategy in place. Let's verify. We get the trace information. We can see that edge service is calling down to instrument service, but then there's something missing. There's no call to the database. So maybe it's the cache. Let's have an even closer look, because we added the cache to one of the endpoints, the instrument controller endpoints, and there it is. So we define the cache. It's super easy, magic annotation, but what happens under the hood is that the key for this cache is based on this parameter. So there's a single cache for all guitars across all customers. Now, this is a super simple mistake to make. Like, we spend all the time on configuring Hibernate and understanding all this database stuff and schema strategy, and then maybe, oh, let's improve performance. Let's add one magic annotation to add caching. And then suddenly we are returning personal patient data to the wrong clinic, and then suddenly we're in jail because we broke the law. So pay attention to this. We need to make also the cache tenant specific. And in particular, I can define a key generator strategy, a tenant key generator that I can define in here as a class, tenant key generator. Let's implement the key generator. And I'm fine with the simple strategy that comes out of Spring by default. But no, not that. I want to implement the method. Yes. But I need to add the tenant ID. So I can say simple key generator, generate key. And by default, it's only based on the input parameters. I also want to add the tenant ID. So I can say tenant context, get tenant ID. Let's restart the application. And actually, I need to configure this as a bin first. Component. Is it restarting? Yes. So going back, now we can verify that everything looks okay. /guitar, and there it is. It's not the fake one anymore. And if we look at the bins, guitars, if I spell correctly, there it is. So apparently, under the hood, the Beans band was looking at their guitars, the cache stored that result, and that was served also to the Duke's band. Nice. So remember, data isolation is the most critical part. If you remember one thing from this presentation, careful about data isolation and about isolating data based on tenants. Now, I'll share the slides. There's different resources if you want to dive deeper into certain topics, like the data part or the security part. Thank you very much for joining. Please, you won a book, so thank you. And yeah, thank you very much for joining.